Okay, well, why don't we
There we
just
go.
start on it here?
There's
Oh, we got a
somebody
couple
there.
people
Okay.
joining in, a couple people joining. Okay, so yeah, so today we are, so first of all, welcome to the Customer Connect webinar. Thanks everybody for joining us. This has been going well for a couple months. This is actually our sixth session now, and we've had some good feedback from it. We've had some good questions, some good discussions, and hopefully we can keep this going as we get some new features and some new products coming out into the new year. And so, I appreciate everybody who's joined us so far, and if you could continue to share it around with Simac users. All we're trying to do here is answer anybody's question about Simac and our simulators. And we really just want to show our users all the things, all the amazing things our simulators can do and how they can make your life, teaching, training, and just practicing with Linac day to day easier. Really, we can just give you a personalized Linac for the palm of your hand, and we just want to let everybody know how to use that. We'll jump into it. And today I'll just also say we have Karen Ann joining us. So Karen Ann's our new technical customer analyst. Sorry about that. And so we're super excited to have Karen Ann on the team. And if you ever need anything, you can always reach out to Karen Ann. So yeah, so I just wanted to talk about what we're going to look at today. So I mean, today our featured demo is around TMR Calcs. So like I said, let me just get this in present mode.
Perché ha detto, ragazzi, se non lo riuscite a fare, non lo fate.
Basta sta voce. Perché urli?
Perché sono...
I just had a little noise coming in. That's okay. But yeah, so our Customer Connect webinar. So today we're going to look at TMR calcs or tissue maximum ratio calcs. So looking at the the ratios between your dose in tissue versus at maximum. And the reason we really want to take a look at this is because it is actually very simple to do on Simac. And the reason we want to highlight is in real life, this TMR calcs are actually they're hard to do because they take a long time, and mainly because you have to change your SSD all the time. It's a difficult setup, and it's very time consuming. And as we all know, TMR calcs they're so complicated. We actually really rely on reference data to confirm that we are looking at correct data when we do measure it. And so with those complicated calculations, we kind of just moved on from doing TMR calcs at all. And now we've just moved to this complicated formula of converting our PDDs from one SSD to another, which that's amazing. We have this great formula. You put in your PDD and you get the results you're looking for. But at the end of the day, without learning the TMR, we actually might be taking away from our physicist's understanding of the linac. And really what we're missing there is, the ability to understand the actual dose to depth relation. So things like SSD and SAD, they're very simple concepts when you look at them theoretically, but when you start applying them to things of understanding those concepts in setups like water tanks versus clinical treatments, there becomes a relationship that needs to be understood more in depth that this formula doesn't really allow us to teach our physicists these days. And so now we can do it on Simac, and what it really allows us to do with Simac is because you don't need a machine and it's a simulator. You can do it for any energy, any field size, any physical setup, very, very simply, and allows you to teach the importance and the process with ease. And really, what we can then do with this using our simulators, we can show how physical changes affect our clinical changes, or like how our physical changes are going to affect our treatments. Right? Because we can make physical changes to our simulator, we can recalculate our TMRs, and then we can understand how those physical changes are affecting our TMRs and which TMRs are going to be acceptable for proper operating points and which ones are not going to be. So yeah, so that's just a little intro I wanted to give on why we're kind of doing this on the TMRs today. And then so I just want to show you. So we're actually going to go through it in two different ways. We're going to do it one using our dose percentage and our PDDs, and then we're going to do it another way using our TG51 setup and our electrometer. So today I'm going to do everything in our variant 6 MV. Just to keep it simple, we'll do a variant 6 MV, and we actually have some variant 6 MV TMR data that we're going to do a TMR on our 6 MV linac and compare it to some real data. So to jump into that, what we want to do here is we want to set a 10 by 10 field size, and then we're going to do 4 SSDs today. So we'll do an SSD of 98.4, or a depth of 1.6, and then we'll do SSDs of 95, 90, and 80, or depths of 5, 10, and 20 centimeters respectively. I'm just going to show the first calculations of both, and then I've done the rest prior, and we'll look at the results. But first, let's just go to our treatment head. So we want to set up our jaws first. We want to set up our field size. We set a 10 by 10. So our defaults on Simac are 40 by 40 fields. So we're going to go over to our treatment head, and we'll go to all of our X1, X2, set that to 5 centimeters, our Y1, Y2, also set that to 5 centimeters. And then what we'll do is we'll do our first SSD, which is here's SSD is also set in the treatment head here. And so we will set that to 98.4, or a depth of 1.6 centimeters. And so now we're going to run this, and we can look at our flatness profile. We'll see it'll slim down because we reduced our field size. And then we're going to grab our PDD data, and Simac actually allows you to export that data. And so I'll show you how to do that, and then we'll investigate that data, and we'll be able to pull out some TMR. So there we can see our field size shrank. And now we want to go up to our photon beam tab, because that's where we find our PDDs. And so we have our nice PDD here, and I'm just going to export it to CSV because I need to get the data from it. So we can do that. I'll just show you guys how. I mean, I could call it like 1.6D TMR. And then I'll just show you what that data looks like. Just so you're familiar. So open that up. It actually gets, exported as a CSV. And then this is what we get out. So we get the depth in centimeters and the dose percentage. So this is great. So now we're looking at, each depth and what percentage. And you can see at our 1.6 is our 100%. So that's our D max, right? So now what we want to do is, because we're just getting the dose percentage, we have to get the actual dose out. And so now in Simac, we're going to go back to our Simac tab, which outputs our dose rate here, the 212.58 centigrade per minute. And so I'm just going to record that. 12, and what was it? 58. And so then what we can do then is at our 1.6 to get that dose, we can then look at, multiplying the dose percentage by the dose rate. Oops. And then we could get that into centigrades per minute, and then all we need to do now is do our other scans for our 3 other SSDs, record that data all again, and then we'll be able to take the percentage ratio from whatever dose we got to then this maximum dose, and then we'll be able to get the TMR percentage. So I've done that already, and so I will show you that here. And so what we're looking at, so there's our first one of our 98.5. It should be 98.4. But we can see, we're basically getting that same dose rate of 12.12. When we did our 95 SSD, we got a 227.57 centigrades. And that was at 5 centimeters was 86% dose. And then looking at our 90 SSD, we had a 253 dose rate, and that happened at 66% of the dose. And then on our 80 SSD, we had a 319 dose rate, and that happened at 37%. So kind of right off the start, it's easy to see that, our results are accurate to what you would expect from a clinical result. As we're reducing our SSD, we're going up in dose, which is to be expected as we go further into the dose into the beam, but we've canceled out our 1/r squared influence due to the fact that we're keeping the chamber in the same spot, right? And so now we can look over on our plot here. And so we plotted our SSDs and our depths, and then we plotted the Simac dose rates that we got out. And then what we did is then we do the percentage dose. So simply, if you look at the 100%, of course, then 93 is just going to be your dose at 5 centimeters depth divided by your dose at 1.6, and then all the way down following that trend. So the dose percentage, right? We look at the dose at 10 centimeters divided by the dose at 1.6. And so we can get all of our dose percentage ratios here. And then in our column U here, we've recorded our reference TMR data from a 6MV variant machine. And then we've gone ahead and plotted these, and then we can show that Simac is producing accurate TMR results for a 6MV variant machine. So that this is great to see that we're accurate. It's not 100% accurate, as you can see, but it's more than enough accurate to show the relevance of TMRs and the relevance of changes to your TMRs and how that would affect the operation of your machine. So that's great. And so I'll just show you really quick on Simac that the other way that we can do this using the TG51 simulator, and we can actually get the same results. You can see here's our electrometer charges at all of these SSDs and depths. And then there's the percentage ratio of the electrometers, and then plotted together, you can see that it is following that same trend. If we zoom in, you can actually see the pink one is kind of hidden and the turquoise one is on top. So the pink one is Simac results. The turquoise one is our TG51 results, and then the blue one is the reference TMR. And so you can see our one done in the electrometer versus Simac is almost identical, which is nice to confirm our beam model does work the same everywhere. And then it's just a little bit off of the reference TMR as you go further down. But what you can see is just we were a little bit off on our further data points, especially at the 20 centimeter. You can see this one was actually recorded at 20.134 rather than 20. So that was where that little discrepancy came from. Yeah, so now let's just go do it on the TG51 simulator. So we go into our Simac and we jump over to TG51. And the setup in this one is actually a little bit more intuitive in a way. So we'll select our machine. So we'll do the same setup we did before. We'll do our 6MV operating point. And then we'll look here. We can confirm we're doing a 10 by 10 field as well. And then we can just go to our TG51 setup. And then simply you can see here that this indicator is at the top of the water. So that's going to be our SSD with a readout down here. And so very simply, we can just set our SSD to that 98.4 or maybe 98.3. And then we can see our ion chamber is sitting at a depth Z below the water surface. And so all we have to do is adjust this up to get our depth we're looking for. 0.4, make a slight adjustment, 1.6, and then that's perfect. And so then what we'll do is we need to turn our electrometer on. This is a big part of our TG51 simulator. We made realistic, as you can forget to turn your electrometer on. So let's turn it on. I like doing 300 volts. I know some people like doing minus 300 volts. Really, the relative changes are going to be the same no matter what voltage you do it at. But I did it at 300 volts. So then all you have to do to now get the charge recording is we're just going to go back to the console. We're going to prep our beam, just like we would on a real console, wait for it to prep, and then we're going to deliver our beam, and we'll watch our electrometer count up, and we'll be able to grab that dose, or I shouldn't say dose, grab that charge, and record it in our table. And of course, on this one as well, you can do it on the Electa, any operating point. On this side, you wouldn't be able to introduce as many physical changes as you would in the other version, but just a little bit different setup. So we'll beam on here, and then we'll come over to our electrometer. And so we can just confirm we're still at the right SSD, we're still at the right depth, and we can see our electrometer starting to count up. It's great. and then it stopped. We can record that now. So 18.906, and we can go there. And so we can see that there's that 18.906. And then if I was going to do the next setup, I would change my SSD to 95, and then our depth would then also increase to 5. So we're keeping our SAD the same, but we're changing the SSD. And then if I were to rerun that, we could then see, like I showed you before, we would plot those charges. We could take the ratios of them, plot them all together, and then we could really show that. First, this is just to confirm that Simac does have a like model of a Varian 6MV. We get very similar results. We won't say that's 100% the same, but it's within a couple percentage. And then we really wanted to demonstrate that you can utilize these different features, like taking our PDD data, doing it in the electrometer versus the PDD, and then you can really expand this to so many different scenarios to allow a student or a trainee to really understand what's going on here and allow and apply these principles to the clinical treatments rather than just following procedures, because now we understand the beam to distance relationship, and we actually understand, you know, why we're collecting these values to then look at applying them to our beam model and creating an operating point for our linac that's going to be safe for patients and accurate to the treatments that we create. So yeah, so I mean that's kind of the overview I had for you guys today. There's a couple people in the call. If there was any questions, please feel free to leave in the chat or put your hand up. You're welcome to just voice them yourselves. That's totally good. But hopefully that was helpful for everybody. And of course, we're going to have this recording available, and I'll send it out to all registers. And then of course, don't forget and just let everybody know, we have a free account on linax.ca. Everybody can get a free account, and you get 5 free simulations per day. And there's a bunch of free labs and exercises that we give you to use on the simulator so that you can practice things. The beauty of our simulator is you can break it, you can use it any time, you can use it at your desk, you can use it after hours. And so, it's right now, it's not going to take away from having to use that machine time, but you can prepare yourself for machine time. You can do those beam runs that you're looking for before you actually get on the machine, so you know what you're going to expect and get through it a little bit quicker and just make your day-to-day with Linax a little bit easier. I just did want to show so anybody with a free account as well, student resources portal from your username drop down. All the webinar recordings are posted here, so you can share with anybody. All these webinar recordings are posted. And then, of course, we have some manuals and guides to help you learn Simac and the platform. And then we also have these procedures, which are some great exercises to do right on Simac. It takes you on Simac, takes you through adjusting the parameters, where to find the parameters, and then looking at the results and why we're seeing the results we are. So they're great exercises for the simulator, looking at beam energy procedures, flattening filters, field size, lots of different great things. So I just want to get that in there. And then just the last thing, I always ask on the registration for anybody who registers to just ask any questions or for any demos on the registration, just because I'd love to cover them in here. And people don't need to be here all the time if they can't make it. I just love people to drop questions. So if you could spread that, that'd be great. But we had a question from Ian this session, just asking about acceptance and commissioning PDDs, like using Simac to get acceptance and commissioning PDDs. And so the answer is, yeah, we're not quite there yet, but we're coming. So the answer I would give is that you can absolutely use Simac for acceptance and commissioning data, but really right now it's only to validate and not rely on, or to try to predict and not rely on. Our models aren't accurate enough to say that the physical changes you make are going to be 100% what a real linac would reflect at. But we are very confident we're in a small percentage error of 3 to 5%. So it could definitely still validate your hypothesis or your setup that you're trying to commission or set up, and it would validate, you know, what the output you would expect. And then in the future, when we do come with some clinical tools and we make our beam model a little bit more accurate, we will move into having those tools where we will be able to say that yes, this will be the result that you're expecting, and you will be able to do these things, but not quite yet. Can we use? Yes, yes, great question. You can absolutely use TRS 398. We call it TG51 just because we're in North America and that's what we call it. But I've been working with people all over the world with this, and I have yet to find really where the difference of TG51 and TRS 398 come in. If you were to go through your TRS 398 procedure on our TG51 simulator, I'm pretty confident that it's the exact same setup with just a little bit of different nomenclature on the form. But I'd love to learn more about that if anybody could confirm that or was interested in exploring the TG51 simulator a bit more to confirm if it would hold up against TRS 398 a bit better. I'd be very curious to explore that. But at the same time, we have a customer in Belgium, and our Belgian customers, they do TRS 398, and they just did a class running it with the TG51 simulator, and we got some good feedback that she was happy with that part of the simulator and how the class went. So okay, well, we're running up on 5 minutes left here. So I mean, I'll leave it open. I'll hang around for a couple minutes if anybody has any questions or comments or anything else. Very happy to sit around and discuss. But if not, thank you so much for joining. We hope to see you at the next one, and we hope that the session was helpful. Perfect. Any questions on your side, Karen Ann? Did I miss anything you think? I think you're muted there.
Yeah, that's good.
Cool.
No, that was clear.
Yeah,
Makes sense.
great. Yeah.
You can tell me though what TRS 398 is though.
Yeah,
That's
yeah,
new,
that's just
a new one.
Yeah, the quality, it's the same quality assurance testing, it's just in other parts of the world.
Oh, I see.
In North America, we call it TG51. They call it TRS 398.
Okay.
Yeah. Hey.
Okay. Bye, gentlemen.
Yeah, if we have no more questions, I think we'll just end the event there, and then hopefully we see you guys next month. And of course, feel free to reach out anytime if if you'd like to explore our products, demos, anything like that, we can absolutely arrange that. Okay. Great day, guys.